feel bad though. Like I said, there was somebody that asked me if today was going to be a work day, and I had said yes, but now we're changing our mind. That's really dumb. Okay. All right, so we're doing, today's lesson is actually going to be pretty straightforward for the most part. You know what's going to, this is going to build on last time's lesson, and I think this stuff is going to be like really where they start testing. Last time was kind of getting you warmed up to the idea of these sequences and series. So an arithmetic sequence has what's called a common difference. So they're going to be using subtraction, not addition here. In a sense, you'll see what I mean. Now, which means that from one term to the next, you are adding or subtracting the same number each time. So, like if it's arithmetic, it has to be adding or subtracting the same number every single time. It can't be just a pattern. Like if you add 1, then add 2, then add 3, then add 4, yes, that's a pattern, but it would not be considered arithmetic. So not all series are arithmetic, only if they meet this criteria. So look right here, 2, 5, 8, 11, comma, dot, dot, dot. So we know that means that pattern continues. Do you guys see how, well, what are we doing essentially? We are adding 3 each time. Now that's actually what's called a common difference. So how we figure it out is we actually work backwards. We'll go 11 minus 8, which is 3. 8 minus 5, which is 3. 5 minus 2, which is 3. And if you are, so that means you're, adding 3 each time. So that's, once again, though, the common difference. So our common difference is 3. So this would be considered arithmetic. Now right here is the general formula. If you're given an arithmetic sequence, if I said to you, write the formula that recreates 2, 5, 8, 11, you literally just plug it into this. So it's really easy because last time we were just kind of guessing, right? You're guessing. Here's the actual formula you'll use. So a sub n means any term in the sequence will equal a sub 1, which is the first term, plus n minus 1. N is the variable. N is what stays n, depending on the term we're looking at. So n minus 1, and then d is your common difference. So in this case, let's write a formula. So I'm going to once again, my formula will recreate this. If I wanted to give it to a random person, they could recreate 2, 5, 8, 11. So you'd say a sub n is equal to, our first term is 2, plus, then we have n minus 1, and then our common difference is 3, so times by 3. Now we do want to get in the habit of simplifying this, so we're going to say a sub n is equal to, we would distribute our 3 in, so then we have 2 plus 3n minus 3, so then you'll combine like terms. So you have 3n, and then it looks like minus 1. So now there's your general formula. So look, that makes sense. If I said what's a sub 1, you'd plug in 1, so that would be 3 times 1, which is 3, minus 1, which is 2. If I said find a sub 2, you'd say 3 times 2 is 6, and then 6 minus 1 is 5. You guys see how it's just recreating it? Cool. All right, so that is a formula you'll want to go into your test having memorized. All right, so right here, let's write a definition for this arithmetic sequence. So once again, now I need you guys to understand, this formula, this is what's really important. This formula right here only works if it's truly arithmetic. You can't just use it for any sequence. Just keep that in mind. So like right here, is this arithmetic? If so, what's the common difference? So negative 6 minus negative 1. Negative 6 minus negative 1. Won't that be negative 5, right? Then negative 1 minus 4. Negative 5. 4 minus 9. Negative 5. So we know it is arithmetic because we were subtracting 5 each time. So writing the definition, that is what the formula is. So we'd say a sub n is equal to a sub 1, which is 9, plus n minus 1 times by our common difference of times by negative 5. So then you would want to simplify it. So you would distribute your negative 5 in. So that's 9 plus negative 5n, and then it looks like plus 5, right? So we would have negative 5n plus 14. Then if you're like, is my formula right, start plugging in 1, 2, 3, and see if you're getting the right things out. So now right here, this is from last time. It says write a recursive definition for the sequence. So recursive just means what do you see happening? And then this is just, it's literally what do you see happening? And you write it in terms of the previous term. So if we're looking at this, aren't we taking we start at 9. With recursive definitions, you always have to tell it where to start. So you'd say a sub 1 is 9. Otherwise, otherwise they don't know how to recreate 9, 4, negative 1, negative 6, because they don't know where to start. So we're saying starting with 9, we're going to take, so a sub n is equal to, aren't we going to take our previous term, so to get to this term, aren't we going to take our previous term and then subtract 5 from that? So that's, how do we write previous term with this type of stuff? We'd say a sub n minus 1, that's saying take the previous term, and we're going to then subtract 5 off of it. So that's what's called the recursive definition. Because once again, now people could use this formula to recreate the 9, 4, negative 1, negative 6, or they could use this formula. Starting with 9, they'll then take the previous term, which is 9, subtract 5. Then they'll take 4, subtract 5. Then they'll take negative 1, subtract 5. All right, now it says find the 40th term. Find the 40th term. You're not going to want to use this formula, are you? You would need to know the 39th term. So we're going to use our straightforward formula. So let's just plug that in. That's a sub 40. We know that that means 40th term. So a sub 40 is equal to, right here we're plugging it in, negative 5, grab your calculator, times 40 plus 14. If you wouldn't mind telling me what that is. Say it again. Negative 186. Check. So we like this formula because it's easy to find any term in the sequence. All right. Doing good. Okay, so now it's just all getting into, it's just getting into a little bit more, it's a little bit more to the problem. So it says right here, if the 11th term of an arithmetic sequence is 52, and the 19th term is 92, find the 100th term. So here's the thing, guys, we're gonna say, well, what information do we have? And we're gonna plug it in. So just recall, our formula to create these things is a sub n is equal to a sub 1 plus n minus 1 times d. I always have that written on each problem. I rewrite it in. So let's plug in what we know. So we know we're like going through and ... we get to a sub 11. Agreed? And we know that that comes out to be 52. Then we're going to 19, so then ... up to, I just don't want to rewrite all the spaces. So then we're at a sub 19, and that is 92. Now it wants to know what's the ... what's a sub 100. So what we want is we're going to put in all the information we know, and then we're going to see if we can write a formula that will allow us to find the 100th term. So let's go and use this information and make a true statement. So what would a sub n be? We're plugging in what we know. What would a sub n be in our formula? It's 52. I was afraid somebody was going to say a sub 11. But this is the ending calculation, isn't it? If you calculate, you get out a number, right? So we're going to plug in 52 is equal to, what's a sub 1? We have no idea, do we? So write a sub 1. Then we have plus, now do we know what n is? Isn't this a sub n? So it's 11, isn't it? 11 minus 1, and then do we know the common difference? No. Okay, so common difference, we don't know. All right, let's set up another true statement. So we have two unknowns here, don't we? Oh, and let's even simplify it. So that's 52 is equal to a sub 1 plus, and then that's going to be 10d. So now notice we have two unknowns. So we can't solve that yet. Let's set up another true statement here. So I'm going to do it right here. Another true statement would be 92 is equal to, we don't know a sub 1, plus we do know n is 19. 19 minus 1, and then once again, times by d. So now look at my true statement. 92 is equal to a sub 1 plus 18d. So let's put that in right under this. So now we have 92 is equal to a sub 1 plus 18d. Now if I said to you, solve for a sub 1, solve for a sub 1, and solve for d, could you? Yeah, this is a system of equations. to solve this in this unit. So now we could just do it however we want. Would you want to do reduced row echelon form? Would you want to do it by elimination? You want to go back to the old school stuff? Nothing from this unit? Are you sure? So, I mean, I'm fine with doing it the old school way. I was just seeing if there was a way. I feel like the determinant is just as quick, the determinant thing that we learned last time, because it's a 2 by 2. But, so should we do that? So you'd say, okay, the original, now remember we usually have equals 52 on this side and equals 92 on this side. So maybe let's practice that way. Okay, so this is our true statement. So you find the original determinant, because remember x, this is what we'll call x. Okay, everybody, a sub 1 is x. So x is equal to dx over d, and y is equal to dy over d. So let's find what d is. Remember, d is the original determinant. So then we would put in our original coefficients, which would be 1, 10, 1, 18. So let's hurry and calculate original determinant. 18 minus, right, 18, the diagonals times, 18 minus 10, which is 8. So we know 8 goes on bottom here. Now let's find dx. So then dx, remember, means find the determinant by replacing the column of x, right? Here's my column x. We replace it with these two things. So we're going to insert those in instead. So that would be 52 and 92, and then we'd still have 10 and 18. So let's grab a calculator. I'm going to need this real quick. 52 times 18, 9. And then minus 10 times 92, which is 920. So what do we get? 16, don't we? So then look how quick that was. What's 16 divided by 8? 2. So a sub 1 was our x, what we were calling x, so we get 2. Let's hurry and do dy. So that means the determinant replacing our y column. So we would still have a 1 and a 1. And then now we have 52 and 92. So then we'll do 92 minus 52, which is 42, isn't it? I mean 40, not 42. My bad, 40. So then we go right here. What's 40 divided by 8? 5. So that was D. So D is equal to 5. I think that's just as quick, personally, but that's just me. So now what can we do? Can we now write our general formula? So we'd say a sub n is equal to a sub 1, which is 2, plus n minus 1, and then times by 5. And all that work was done so that we can now find the 100th term. So now couldn't I just plug in 100? Yeah, I could simplify it, right, if I wanted. So then we would have a sub n is equal to 5n minus 3, because I added negative 5 plus 2. So then from there, go ahead and plug in 100, because we're finding a sub 100. So 500, right? 5 times 100 is 500 minus 3. So wouldn't that be 497? So 497 is our final answer. So a lot of times it just takes a lot more work to get to your answer because you've got to go plug in what you know. All right, another one. You guys are doing great. Just because they're all a little different here. Come on, computer, let's go. All right. Now, guys, this is important. So it says, a sequence of arithmetic numbers becomes a, quote, series when instead of having commas, we insert instead addition signs. So right here is just a sequence of numbers. We're not doing anything with them. But now right here, we've changed it to a series because now we're saying take that pattern and add those numbers together. Remember, this is called a partial sum from last time. So recall, you can rewrite this in summation notation. Remember, summation notation is the exact same thing, just written in a different form. So if I said you find the sum, you could add those up by hand. I'm not asking that. I'm asking us to rewrite this in summation notation. So what do the addition sign mean? We need to write a sum sign, correct? And then we go n equals. Now how many terms are we adding up? 1, 2, 3, 4, and 5. So we're going to start with 1 up to 5, right? These always have to do with the number of terms we're adding up. Just to recall, this has nothing to do with these numbers. It has to do with how many terms you're summing up. And then right here goes the formula. So we know the formula. Is this arithmetic? Is the pattern arithmetic? Yeah, there's a common difference. 17 minus 13 is 4 and 4 and 4. So now you'd say the formula that recreates 1, 5, 9, 13, and 17 is a sub n is equal to a sub 1 plus n minus 1 times d. So our a sub 1 was 1, so we're writing a sub n. I'm going to do this on the side. A sub n is equal to a sub 1, which is 1 plus n minus 1 times 4. So now simplify it. We always simplify it. So then we have 1 plus 4n minus 4. So then we have 4n minus 3. So that's what you insert here is 4n minus 3. Now that's not anything different than this. They're the exact same thing. It's writing it one way versus writing it another way. Okay. Okay, so let's go the other way. If I give you something in summation notation, so right here it says find the sum from 1 to 4. That means for 4 terms, correct? Given this formula, we could write it out and do it the long way. So let's plug in. How do we find the first term? Plug in a 1, so that would be 2 times 1 plus 3, 5. Now we'll plug in a 2, which would be 2 times 2 plus 3, 4, 5, 6, 7. So what did they do? They added 2, didn't they? Instead of plugging it in, do you feel confident just adding 2 again? So that would be 9. Add 2, 11. So if I said to you find that sum, what would that be? What is it? You're right, 32. So they're the same thing, guys. This equals 32, this equals, they're the same thing, right? So the answer is 32. Now write this down. We're not going to do it the long way anymore. This is what's considered the long way. Now yes, it seems short because I asked you to sum up 4 terms. They're going to make sure that you cannot do it the long way. They're going to give you 100 terms to sum up or something big. So that's why we're learning this formula. So write it down. This is the sum formula for arithmetic sequences. So instead of having to actually go through and do it by hand, we're just going to plug it directly into our sum formula from here on out. Because, once again, right here it seems easy to write it out, but if I give you 100 terms, you're going to run out of time on your 1050 exam. So you're going to have to use this formula. So S of n, so S of n, that means the sum of n number of terms, is equal to n over 2 times by a sub 1 plus a sub, and like I just write in, it's always the last term. So basically, guys, this is the first term in the series you're adding up, and this is the last term in the series you're adding up. Just the first and last thing that's being added up. Now, this is what's really important. N is the number of terms that you are summing up, the number of terms you are adding up. So let's practice finding this answer, but with this formula, just so you can see how it works. So we're finding the sum of how many terms? 1 through 4 would be 4 terms, right, everybody? So you'd say the sum of 4 terms is equal to, plugging it in, we would do 4 over 2 times a sub 1. Now, a sub 1 means the first term. What was the first term in this? 5. How did you get 5? You took this lower limit, you plugged in 1, correct? So we have a 5 plus. Now, what was the last term? 11, right? Well, you would take the upper limit and plug in 4. Does that make sense, everybody? All right, so now if you do that, that's 55. Whoa, not 55, I'm timing that. So that would be 16, and then 16 times 2, because 4 divided by 2 is 2. 16 times 2 is 32. So we get the same answer, because it is the same answer. Just using the formula to find it instead. Okay, so from here on out, we're going to use that formula. So let's read this. It says find the sum of 40 terms. So how many terms are we summing up? So the sum of 40 terms is equal to 40 over 2 times a sub 1. What is the first term in this sequence? 3. Agreed? Then plus, what's the last term? We don't know it. Can we find it real quick? Yes, we're going to have to go off to the side and say, we're going to use this formula. We've got to find the 40th term. So we'd say a sub 40 is equal to a sub 1, which is 3 plus 40 minus 1 times by the common difference. Isn't the common difference 4? So times by 4. So now we'll calculate that. 3 plus 39 times 4. So what would that be? The 40th term is what? 159? 159. Thank you, Axel, for helping me out there. So we had to push pause and find it. So guys, notice on all of these, when I get to a test, if I see it's arithmetic, I write down both formulas for myself. Because you're oftentimes going to use both. Because notice we use this and this in this problem. Okay, so then you would just go ahead and calculate that. So obviously that would be 20 times by 59, 60, 61, 62. 162. So the sum of the first 40 terms is equal to 3,240. Is this making sense to everyone? Okay. Find the sum of the first 50 odd numbers. So let's see if we could do this one. So what would be, so you'd say, okay, so the sum of, okay, Axel, I like what you're doing. You're saying, so we're looking at 1 plus 3 plus 5 plus ... plus up to the a sub 50, right? Oh, the first 50 odd numbers. Yes. So there would be 40, wait, would there be 49 or would there be 50? Good point, because you're saying, well, it says the first 50 odd numbers. So you would go up to the 50th odd number. Does that make sense, everyone? So, okay, so we say it is the sum of 50, because we're doing 50. So then 50 divided by 2 times a sub 1. What's the first term? 1 plus, now we have to do the last term. Do we know what the last term is? No, now we're not going to want to write it out. We're going to hurry and plug it into, once again, our formula. So we'd say a sub 50 is equal to a sub 1, which is 1, plus then 50 minus 1, and then the common differences, aren't we adding 2 each time? Times 2. So right there we would get 49 times 2 plus 1. 99. So then we have plus 99. So then you would just do it in your calculator. 50 divided by 2, 25 times 100. So 2,500. Okay, good. So it's just seeing if you can use some critical thinking there. Awesome, you guys are doing good. We're winding down here to the end. Okay, just making sure this one takes a little bit more effort. It says find the sum. Actually, no, not, well, yeah, it does. Here's why. Now we're missing a couple different things. So the sum of how many terms here? But that's not necessarily 68 terms, is it? No, because it depends on how far we're jumping, right? Like maybe we're adding 10 each time. Does that make sense? So let's see, what could we do here? Well, there's a couple different things you could do. You wouldn't want to have to go out and count, write this out by hand and count. That would take too long. So let's plug in. What you would do is say, I can't do my sum formula yet. Let's go back to this and plug in what we do know. All right, so what is a sub n? 68, right? 68 is our final term we're trying to find. So we say 68 is equal to, what's a sub 1? 2 plus, now do we know what n is? No, that's what we're trying to figure out, right? If this is a sub 20, that's the 20th term, right? So we have no idea what n is on this one. So n minus 1, but our common difference is 3. So now do you guys see how the only unknown is n now? So now we would solve for n. So I'm going to go 68 minus 2, so we'd have 66 is equal to n minus 1 times 3. Can't I divide by 3 next? If I wanted, yes. So 22 is equal to n minus 1. So then n must equal 23. So this must be a sub 23, everybody. So that means we're summing up 23 terms. So we'd say the sum of 23 terms is equal to 23 over 2 times a sub 1, which is 2, plus the final term, which was 68. So in this one, the unknown was n instead of the last term. So do you guys see how every problem can just be a little different? And notice, most of the time, we've ended up having to use both formulas. So now you'll do 23 divided by 2, and then times by 70. So that would be 805. So if you're ever missing something for your sum formula, go back to your general formula and plug in what you do know. Okay, you guys are doing great. All right, we probably aren't going to do this one. I'm just going to see if you could at least set me up a true statement. This one's really easy. How many people can be seated in a theater that has 32 seats on the first row, 34 seats on the second row, 36 seats on the third row, and so on if there's 50 rows total? So what do we want to be adding up so we know the total number of people? So this would be the sum. So wouldn't we'd be summing up how many terms? 50. The sum of 50 is equal to 50 divided by 2 times a sub 1. What was a sub 1? 32. Plus, what's the final term? We don't know, so what we do is go back to this formula, isn't it? So we'd say we need to find out what a sub 50 is, which is a sub 1, 32, plus 50 minus 1 times by our common difference. Aren't we adding 2 each time? So then you calculate that. So that's 130. So then now we're good. We would just plug it into our calculator. Okay. How many terms of an arithmetic sequence 5, 7, 9 were added if the sum came out to be 572? So in this one, we're given different information. So once again, how many terms of an arithmetic sequence 5, 7, 9 were added if the sum came out to be 572? So what does this kind of look like? 5 plus 7 plus 9 plus ... plus something, right? Equals 572 total in the end. Isn't that what it looks like? Kind of our true statement-ish. So let's see if we can start by, let's go to, aren't we trying to figure out in the sum formula what n is? Because it said how many terms did you sum up? So we're like saying, in the end, what was our sum? So you're saying you want to find this real quick? Because we will end up probably needing that, won't we? Maybe? Right. Good point. Okay, so let's go to here since we know we're using this formula because it's a sum, right? So you'd say we don't, S of n, what does the sum come out to be? So 572 is equal to, and then we don't know what n is, n over 2. Now a sub 1 is 5 plus, and then we don't know. So plus a sub last term. So we have 2 unknowns, don't we? Okay. So if that is true, then we must have to go back to our explicit formula and figure this out here. Let's see, how can we do that? Well, a of n is not, that's the sum, right? That isn't a term. You guys see what I'm saying? That's not a term. So this right here is a sub n, isn't it? So we don't know what a sub n is, but it's the last. So let's set up a true statement. Isn't it going to be the last term though? So we'd say a sub last term is equal to a sub 1, which is 5, and then we have plus, and then we don't know what n is, do we? It's a sub n. n minus 1, these are different n's though. N is the number of terms up here, and n is the nth term down here. And then times by what's the common difference? Times by 2. N is the number of terms. But you guys see how both true statements have the same unknowns, n's and eighths of n's? I think this is another system. The only thing that's throwing me for a loop a little bit is n here is the nth term, n is the number of terms. They're the same n though, essentially, aren't they? If this is a sub 100, we're summing up 100 terms, aren't we? So we have two true statements. So shouldn't we solve by, what can we plug in for the last term then? This is substitution. Can't I replace this with that? So we have 572 is equal to n over 2 times by 5 plus 5 plus, do you guys see what I'm doing? Instead of this, I'm rewriting this. N minus 1 times 2. And then that's in parentheses. So now solving for n. So some algebra here. Then, isn't solving for n what we're looking for? Yes. Okay. Let's do it. So I'm going to first of all times by 2 to this side, so I don't have to deal with fractions. So 572 times 2. So that's 1144. You guys see why I can times both sides by 2? Divide 2, so times up by 2. So that's equal to n times 5 plus 5 plus, I'm going to distribute that, 2n minus 2. That's all in parentheses. So we have 1144 is equal to n times by 10 minus 2. 8 plus 2n. So now we would have to distribute. So we have 1144 is equal to distribute. 8n plus 2n squared. How do we solve when we have a quadratic? Yep, but we first have to get it set equal to 0, right? And put it in standard form. So we have 0 is equal to 2n squared plus 8n minus 1144. So can I divide everything by 2? Yes. For solving I can. So then we would have 1144 divided by 2. We're almost done here. So we have 0 is equal to n squared plus 4n minus 572, because essentially I factored out the 2 and then it won't matter for solutions. So then from here, either you can factor a quadratic formula this bad boy. Since it's such big numbers, would you rather quadratic formula? So that you don't have to try to figure out the factors. It will quick factor though. But what do you guys think? Quadratic formula or factor? Okay. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, so that'd be all over 2. So we have x is equal to negative 4 plus or minus the square root of, let's calculate that, 16 So that comes out 2304 all over 2. This should come out perfectly since it does factor. What is it? So x is equal to negative 4 plus or minus 38. 48 all over 2. So then we have negative 4 plus 48 divided by 2. So x equals 22. Then we have negative 4 minus 48. Enter divided by 2. And you get negative 26. Now, how many terms are we summing? Isn't this how many terms are we summing up? So would it make sense to sum up the negative number of terms? So we throw out that solution. So it must be 22 terms. So notice at first I was hesitant until I started plugging things into what I knew. And then I was seeing, we just have another system of equations. So a lot of times, you're going to be using both formulas, and you'll just plug in everything you know. That is the last example. So 22 is the answer. We are summing up 22 terms. Now, how could you check if you got it right? Yeah, now you'd hurry and go, okay, I got to find the 22nd term, right? Then once you know the 22nd term here, then you can go and plug it into your sum formula right here. You'd say 22 divided by 2 times a sub 1, which is 5, plus whatever a sub 22 is. And if it comes out to be 572, you've done it right. Okay, now question, this one's truly my last example. I know it's been a little bit long of a lesson, but you guys are awesome. We'll have 2 work days. Tomorrow and the next day will be work days. Okay, so here is what throws people for a loop. If I give you this is where you need to focus because this is really easy, but there's a lot of mistakes. It says, find the sum of n equals 2 to 18. So doesn't that mean we're adding up the second through the 18th term? Now right here, guys, notice the formula is linear. Anytime you have a linear formula, that is officially making it arithmetic. Because think about what the general formula looks like. A sub 1 plus n minus 1 times d, which ends up being, like when we distribute our dn minus, like, and you'll combine like terms, so like you'll get something linear here. So if you see a linear thing, you can say that's arithmetic. Well, if it's arithmetic, you can use your sum formula. So the S of, how many terms are we summing up? This is where people mess it up. How many terms are we summing up if we're summing up the second through the 18th term? No, that's the common error. 17, because you are also counting the second term. Does that make sense? Starting on the second term, you're going up to 18. Does that make sense? So this is how you can do it. Take the top minus the bottom and then add 1, because that doesn't account for starting here. Does that make sense? So 18 minus 2 is 16, but then you have to add 1. So we're summing up 17 terms. So 17 divided by 2 times a sub 1. How do I find the first term? Plug in what, though? 2 isn't the second term where we're starting, everyone. So plug in 2 into the formula. So that would be 2 times 2 minus 2. 4 minus 2 is 2. Plus, and then we need to put in our last term. Isn't the 18th term the last term? So we take 18 and plug it in. So 18 times 2, 36 minus 2, 34. And then you would just calculate that in your calculator. Now, once again, keep in mind, this sum formula only works for arithmetic. It's only arithmetic if it's linear. All right. I'm getting a sum of 306. All right, that really is the final example. So now tomorrow and the next day will be work days, so I don't feel like you really necessarily need to do homework at home if you don't want. Okay, that's the end.